g of x is 12 times the square root of x minus 6x. Absolutely ew. Same three sections though. Notice we have a square root. It makes things more interesting. Part A. Oh, I didn't call it A, did I? I called it 1. 1. Domain. Do we have any fractions? Do we have any radicals? Do we have any logs? So we don't have to worry about radicals. We have a square root. The square root of a number can't be negative. It has to be greater than or equal to 0. Well, what's the argument of our radical? What are we taking the square root of? Which one? X. So it's nothing fancy. So if it was like 7x minus 6, then we have to do something fancy to it. But since it's just x, then x has to be greater than or equal to 0. So one more time, if that were the square root of 7x minus 6, then you would have to set 7x minus 6 to be greater than or equal to 0 and solve for x. So what this says here is we lopped off half of our number line in step 3. When we draw a number line, we don't pick any numbers to the left of 0, because we can't have any numbers to the left of 0. That's what this part says. Okay. 2. Critical numbers. Find the derivative. See where it's 0. See where it does not exist. We will do this together. Keep in mind, I'm going to write this right here. G of x is the same thing as 12x to the 1/2 power minus 6x. So square root is a 1/2 power. Taking the derivative, what do we get? 6x to the negative 1/2 minus 6. It's easier if you write this back as a fraction, 6 over x to the 1/2 minus 6. Now that's something new for us. Anytime we took the derivative using the power rule, we just left it alone. However, to solve for x in the first part here where the derivative is 0, it's better if you rewrote it as a fraction. So we're going to set 6 over to the 1/2 minus 6 equal to 0. And we're going to solve for x. So if we brought this 6 over, we'd get 6 over x to the 1/2 equals 6. Then if we multiplied both sides by x to the 1/2, we would get 6 equals 6x to the 1/2. Then what should we do? Divide by 6, so we have 1 equals x to the 1/2. Anytime you want to get rid of a fractional exponent, or any exponent, really, you raise both sides to the reciprocal. Cough, cough, your homework, cough, cough, as some of you may already know. So what's the reciprocal of a half? 2, so we're going to square both sides. Class, what is 1 squared? 2 people, very good. So x equals 1 is a critical number. Are we done in step 2? Close. We have to see where it does not exist. This goes a lot faster. The other benefit to rewriting the derivative as a fraction is that you can see that it's a fraction. So what's bad for fractions? 0 in the denominator. So what would make x to the 1/2 0? X equals 0. A 1/2 is really a square root, as mentioned before, but we don't have to do anything extra because we already said negative values are bad. So we don't have to say negative values are bad here as well. That's already taken care of in the first step. Okay. 3, number line. So again, due to step 1, we do not need anything to the left of 0. So I'm just going to put x's there. We don't want this. So I need a number between 0 and 1. Sure, and I need a number to the right of 1. 2 it is. Where are we going to put these numbers? Into the derivative. You're just looking for signs. Positive, negative. At x equals 0, There's nothing to the left of 0. But to the right of it, the graph is increasing, excuse me. And notice 0 is in the domain because x is greater than or equal to 0. So at x equals 0, it increases to the right of it. So what actually happens at x equals 0? It'd be a minimum. Because if this were x equals 0, it increases to the right of it, then it has to do something like that. Which means that would technically be a relative min. Correct. So we don't know nothing happens to the left of it. So x equals 0 is a relative min. So if you put 0 back into the original function without a calculator, what is 12 times 0 minus 6 times 0? 0. So where exactly is your relative minimum? 0, 0, relative min. Very good. It always looks like an owl when I draw it. There we go. Ooh. Okay. How about 1? Increase, decrease, relative max. Oh, I didn't mean to write equals there. Relative max. Without a calculator, what is 12 times 1 minus 6 times 1? 6. Look at that. So where's your relative maximum? 1, 6. That doesn't look like an owl. Can't do anything with that.